Okay, let's talk about quadrilaterals. There are many types of quadrilaterals. We have rectangles, parallelograms, squares, rhombuses, and even trapezoids. Now, some people say that they can be broken down into different categories. You have quadrilaterals at the top, and it breaks down to other different polygons or quadrilaterals. Like a quadrilateral is in a parallelogram, which turns into a rectangle, which turns into a square. And that's where some people say a square can be a rectangle, but a rectangle cannot be a square. We also have interior angles, and we have exterior angles. Now, interior angles are on the inside of the polygon, and the exterior angles are on the outside of a polygon. The interior angles are going to sum up to, or add all of them together to be n minus 2 multiplied by 180. Now, the exterior angles are all going to add up to 360 no matter what. And that's the interior and the exterior angles.
So here we're talking about examples of interior angle problems. So we know that the sum of the interior angles is going to be n, which n is the sides, minus 2 times 180. Okay, that's going to be the sum of, let's call it the eye angles, interior. Anyways, if we have 1, 2, 3, 4, 5 different sides, that means that this is an n equals 5 because it's a 5-gon. Or it's a pentagon, but it doesn't really matter. So if it's a 5-gon, then we know that we're going to have 5 minus, we can start off with the n minus 2 up top, times 180. And then that's going to turn into 5 minus 2 times 180. And then we'll have 3 times 180, which is going to equal 540 degrees. So this angle plus this angle plus this angle plus this angle plus this angle will equal 540 degrees. Let's say we had something crazy like a 15-gon. I don't even have to draw that. I mean, a 15-gon is going to be like, how many sides? Did I get them all? I don't know. But if I add up all these things together, what's a 15 going to be? Well, it's going to be n minus 2 comma times 180. And then we put a 15 in there instead of an n times 180. And we get 13 times 180, which is going to equal 2,340. That's how many degrees all of the 15-gon will add up to. Now let's say we have a problem like this. Let's say we have, now we have 1, 2, 3, 4, 5, 6, 7. So here we have a 7-gon. How many, what is the sum of all these angles added up together? That's going to be 7 minus 2 times 180, which equals 900. Okay, so now I'm going to say this all is going to add up to 900. So I'm going to have x plus 143 plus 2x plus 152 plus 116 plus 125, I'm running out of space here, plus 140 plus the last one is 139 there. That is all going to equal 900. So I add these all together and it should equal 900. Just like adding up all these, the sum should be 900. So if I do some math here, I find out that this all equals to 3x, 1, 2, 3x. Add all these guys together and we get 815, which is going to equal 900. And if we do some math, we get 3x is going to equal, let's just skip to the end, 28.3. Or 28 and a third is the answer for this one. Now, if we're going to talk about exterior angles, here are some exterior angles. Exterior angles is easier. Exterior angles always sum to 360 degrees. Awesome. So if they always add up to 360, boom, let's do this. We're going to have 58 plus 39 plus 50 plus 48 plus 59 plus x is all going to equal 360. So if we just add all these things together, we're going to end up getting 2x, which is these two x's over here, plus 254 is going to equal 360. And then we have 2x equals 106. And then we divide both sides by 2. X equals 53. So all of this plus this plus this plus this plus this plus this plus this will always equal 360. I don't care if it's a million gone. Okay, let's check out some other stuff.
Let's talk about some properties of parallelograms. If we have a parallelogram, then opposite sides will be congruent. Also, if we have a parallelogram, then opposite angles will also be congruent. If we have a parallelogram, then the consecutive angles are going to be supplementary, or x plus y will equal 180 degrees. Lastly, if we have a parallelogram, the property states that if the diagonals bisect each other, they cut each other in half, and they'll create two congruent segments.
Okay, and this is where it gets even easier when we're talking about parallelograms. Parallelogram. Okay, if I just draw a parallelogram here, just to explain all the different properties, it's drawn white. And we know that if it's parallel, then opposite sides will be parallel. Parallelogram. That's the definition of it. But there's other properties that we learned about it. If it's a parallelogram, then opposite sides are congruent. That side is congruent to that side. If it's a parallelogram, then opposite angles are also congruent. Oh, let's make that 3. Make this one 3. And what else did we learn? We learned that even the diagonals are going to bisect each other. That means that this will be congruent to this, and that will be congruent to that. Is there anything else that we learned? Oh yeah, we knew that if this was angle A and this was angle B, then we knew that angle A plus angle B is going to equal 180 degrees. Alright, cool. Well, then what's A going to equal here? A is going to equal, well, it's going to equal 55. And we knew if this is going to be, these are going to be the same. We know these are going to be the same if this is a parallelogram. Down here, H has got to equal, well, if this has got to be 7, and that's going to be the same as this, then H has got to be 9. 16 minus H is 9. 16 minus 9 is 7. And then G's got to equal 61. Because we know that this angle is congruent to this angle. And that's really all it is dealing with parallelograms.
Now, if we put it all in reverse, if we want to prove that things are parallelograms, we can say if two sides are congruent, or opposite sides are congruent, then we have a parallelogram. If opposite angles are congruent, then we have a parallelogram. If we have two opposite sides that are congruent and parallel, then they are congruent. Also, lastly, if we have two sides that are two diagonals that bisect each other and they create two segments that are congruent, then we have a parallelogram. And that's how you prove parallelograms.
Now we're doing the reverse. Now we're saying, like, if we have some type of quadrilateral where all those special things are going on, like this is congruent to this, and that's congruent to that, that's parallel to that, if this is congruent to this side, and this side is congruent to this side, And the diagonals, they're going to bisect each other. Okay? Then we have a parallelogram. Okay, before we said parallelograms, then we got this. Now we're saying if we have this, we have a parallelogram. The converse is also true. So do we know that this is a parallelogram? Yeah, because this is congruent to, we'll say this is congruent to this, and this is congruent to this. They're both 100. Yes, parallelogram. Here we have congruent here, congruent here, congruent here, congruent here. Yes, it's a parallelogram. Here, oh, the diagonals are bisecting each other. Yes, this is a parallelogram. Here, how could I prove that this is a parallelogram? Well, look at here. If we have this is congruent to this, well, that's one thing. I only know that this angle is congruent to this angle, but let's extend it out. Look at this. If I extend this out here, extend this out here, extend this out here, oh, this is alternate interior angles, and this is a transversal. Now, don't you remember the converse to transversals? If we have a transversal where alternate interior angles are congruent, then this is parallel to this, and therefore it is a parallelogram. And that's it for you, folks. Have a good one.